Okay, so but before starting, well, let's just speak a little bit about data analysis and this field of rather data science. So this or data analytics. So this field is very useful nowadays, especially with this widespread or use of data. So in the past, the data was, let's say, in few chunks, so to speak. But nowadays, with the advancements of technology, we can have a lot of data to deal with. Therefore, this field of data science has become, let's say, crucial not only in research but also in other fields. And there are some top five, let's say, data analysis programs that I think you need to upskill in them, namely Python, R, SPSS, Excel, and Power BI. So these are like the top, let's say, five, let's say, programs that can be used. I'm going to share with you the link to download SPSS version 26. So I think it will be compatible with your devices. So then I'm going to, let's say, just as a brief overview of this. So the first step that I'm going to follow is that I'm going to show you how you can first design a questionnaire, then how to code it automatically, how to import data to SPSS, etc. So this is like the first section. And then how to define variables and values on SPSS. So let's go to a browser. So uh, as you know, to design a questionnaire, before designing questionnaire, you should in fact be familiar with the research variables in your study, research objectives and research questions. And you should also define variables because students may not be aware, researchers may not be aware of the different types of variables because we have different types. We have independent and dependent variables, and we have different levels of measurement. But if you don't know, let's say you don't know a lot about this, you just go and adapt a questionnaire. Suppose that we are studying anxiety among students in, let's say, speaking or writing. So what we can do is that we can just go to Google Scholar and type in a questionnaire adapted, and I'm just going to look for an example. So I already downloaded one from this list with the high citation, and you can also cite it from here. You can just check this icon and copy and paste the citation in different forms, okay, and paste it to Microsoft Office Word. So this is on the one hand. On the other hand, I'm going just to go, let's say I already downloaded this study from the Google Scholar. Well, we can know about, let's say we can study, let's say read it, and then we can go directly to appendices because in appendices there are like some scales that are being used or that were used by other researchers. So simply you can just take this questionnaire, you cite that it is adapted from this and this study, and then you can transfer or rather transfer these questions into Google Forms so that you will be able to share this questionnaire with other respondents. So then we can go to Google Forms, okay? Then we can start, let's say, transferring the questions from the Google or rather the PDF to the Google form. So just to put the title, the questions. So we start usually with demographic variables like gender, age, education level, etc. But sometimes we put them at the end. So either way, you just choose the one that best suits you. And why we should, let's say, use demographic variables because some researchers ignore them because these variables are going to be used in or while conducting some tests like when we have gender, for instance, we want to see whether or not there is any statistically significant difference between male and female respondents when it comes to their gender as well as their anxiety levels, so to speak. Are female respondents, for instance, let's say, more anxious than male students, for instance, you see? So this hypothesis can be tested using an independent samples t-test as a parametric test or the Mann-Whitney U test. I'm just trying to make this, let's say, I know I'm using some terms, but this is just for conscious or consciousness raising, just to be aware of these terms. So then we can ask the respondents another question about their age. So what is your age? And please just keep age an open-ended question like this. Okay, short answer, so that the respondents can actually type their age. And the reason behind this is that the age variable is going to be a continuous variable. And if you want to, for instance, do some tests like correlation between age and anxiety levels of students, you can do it. For instance, who is more anxious, okay? Young people or young students or let's say adults, or because there are different depending on whether you are studying a primary school case or secondary or university, you see. So age should be put this way, because you can, if you put it an open-ended question like this on a spaces, we can even categorize it in the sense that we can put categories from 18 to 20, for instance. This still can be applicable, but imagine that you don't put it in an open-ended format like this, and you give respondents choices. You won't have choice, like you put 18 till, for instance, 20, for instance. So this way is not a good way to let's say put this age variable. Please try to put the age variable as an open-ended question, because of course the respondents will be made aware that no personal data will be collected. That's why they will feel comfortable with posting their exact age. So anyways, then we have other variables like education level. Okay, education. So education can be considered again as another variable, which is a categorical variable. So all these variables are called categorical or nominal variables in the sense that they consist of categories. For example, gender is a categorical variable in the sense that it consists of two categories, namely female and male respondents. But for age, this is a continuous variable. You can make it a categorical variable when you give the respondents the ranges, but it's better that you keep it a continuous variable, because you will need it in conducting some tests like correlation, Pearson correlation or Spearman correlation tests, okay? So that's why you should be aware of these things before even collecting your data. Then for the education, again, you put different education levels like 1, 2, 3, etc. This is again a categorical variable, but it consists of more than two groups. So this variable can be analyzed using a one-way analysis of variance. Why? Because there are more than two groups. So we can use this test on SPSS, which is called the one-way analysis of variance, or ANOVA. And if you are reading some papers online, you may come across this test. All right. So this is for education. Then once we finish, I'm going to import the Likert scale. So the Likert scale items, I'm just going to choose a format and linear scale like this from 1 to 5. And then I'm just going to go to that questionnaire and copy and paste the items to the Google form. Okay. Sometimes we can do this automatically by copying and pasting many, let's say, items at the same time. Like this Likert scale should be coded from strongly disagree, okay, to strongly agree. And I will tell you why I code it this way. So the reason behind starting with 1 as strongly disagree and 5 as strongly agree is that this scale will be considered so the coding will be meaningful. So if when we start computing this statistically, when we get 1, automatically this means that the majority of the respondents disagree. 2, it's in between. 3, in between. 4, agree. 5, strongly agrees, because this Likert scale item will be transferred into another variable that will be called a continuous variable, because researchers are not going to keep analyzing all the Likert scale items one by one, but they can combine them. So Likert scale items can be analyzed separately, or they can be also analyzed as a group. And in this sense, we talk about composite variable. So just I'm telling you this just to have this in mind before actually doing your study, because once you collected the data, it's done and you can do nothing about it. And there is this famous quote that says gold in, gold out, and garbage in, garbage out. So if the input is not good, or you won't get good output automatically. So anyways, so once we finish the questionnaire, then I'm going to have so I'm going to share, by the way, this questionnaire with the respondents from send this icon, and we can shorten this address and copy it and paste it to social media platforms, the Google Classrooms, etc. So I'm going to repeat this step. So once we put all the questions, I'm going to go to send this icon and shorten this link and send it to respondents later. So once the respondents fill in the questionnaire, I'm going to come up with this list of responses. Then I need to import this to Excel. So I'm going to check this icon, and I'm going to have the Google spreadsheet page like this, and I need to import this data or download it to my laptop. So I'm going to go to File, okay, Download, and then there are different types. So I can choose Microsoft Excel, okay. I'm going to tell you why I have chosen this, because we will need it in coding. So I open the Excel, let's say form, enable editing, and now I need to code these variables, because I'm not going to enter them as like this on SPSS. I can import them like this on SPSS, but I won't be able to do many things with them. So I need to code them. So I show you an automatic coding on SPSS. So you just can select everything and you go to replace. Okay, you select the whole row and columns, for instance, and you go to replace. And let's start coding. Of course, you should have already a code book, but based on experience, I can do this automatically. So just, for instance, code one as female, and like this, and you can just replace all at once. So couldn't find and click existing, so female. Sorry, so I just reversed them. So I should find female. Okay, I'm just going to, because some students may be watching on their mobile phones, they cannot actually see what I'm doing. So anyways, so I need to replace this with one and click replace all. And then we come up with the whole replacement. Again, for the female or the male group, I'm going to type male, and I'm going to type 2 as the code. So, and replace all at once. So here we coded this variable, gender. I started with female because you should start with female, because female as a word consists of that morpheme male. So you will have FE1, which is not good. So anyways, then you, for the age, because it's already a continuous variable, I need just to do data cleaning. It's called data cleaning because respondents can enter some variables like this. There may be some missing values till I make sure that the age is cleaned, because I will need to use it as. So once I finish the data cleaning, so now you have the idea of how you can do this. For the Likert scale items, I'm not going to keep coding one by one. I mean, one statement, so individually or separately. I'm going to select everything. So I'm going to select everything at once, like this. And I'm going to do what? I'm going to do the same or follow the same step. I'm going to go to find, replace, and I start with strongly. So I think it's about strongly agrees. Yeah, so strongly agree. and I would replace it with so if I were to start with this, I would replace it by what? If you remember, it's 5. Okay, so we replace everything at once. Then we go to strongly disagree, and we replace it using the code 1, if you remember, and then replace all. Then once we replace strongly disagree, we can go and look for disagree. Okay, disagree. Okay, but this order is important because it will help you code this properly. Otherwise, you will miss some parts or make some mistakes. So disagree is going to be replaced by what, if you remember? So we have strongly disagree as 1 and disagree as 2. Okay, and replace all at once. And after that, we still have just agree. Because why I started with disagree? Because disagree as a word consists of the word agree. If I were to start with agree, I would have this 1, which is not correct. That's why I told you that you should follow this order. So instead of disagree, I am going to code agree as what? As, if you remember the code for agree, it's 4. Okay, so and replace all. But for you, you should put the code in front of you so that you can keep following. It's better that you put the questionnaire in a document, in a Word document, coded, so that you can just follow the steps there. And then the last one is neutral, and it should be coded what? 5 or 4, or rather 3. Just so this is how we code. Okay, I'm showing you every step that you should follow when it comes to data coding. So once we finish coding everything, I need to import this SPSS, or rather this Excel, to SPSS. So I'm just going to go to, I'm going to open SPSS, and I'm going to go to File, Import Data, and Excel, and then look for the Excel file so that I can import it. So I put it on downloads. So I'm going just to look for it like this and click open, and it will start loading on SPSS. Otherwise, there is another technique. I'm going to show you this technique as well. Okay, if we go to another sample, so we have just, I'm going to just go to the questionnaire, right click, and then go to open with and SPSS. So these are like different strategies, so you can choose which one that suits you the best. And we just wait because SPSS takes time for it to be open. So anyways, so I will have this window. You see, I'm going just to say okay and wait for it. So once it's imported to SPSS, I need to do another step. So there are two windows. We have the data view and the variable view. So the data view here are the Likert scale items coded from 1 to 5. And the variable view, I need to enter the codes or the labels. So I'm going to go again put 1, which was coded as what? If you remember, strongly, okay, disagree, add, and then 2. Okay, I'm just going to zoom this for you. It's better that you watch this workshop on a laptop. Okay, so 2, and then I'm going to put disagree, add, and then 3, neutral, and then add. 4, agree. So just need to put for the value, the number, and for the label, the code that I have, or rather the labels that I have about the code. And the last one is 5, which should be coded as strongly agree. Okay, and then click add. But guess what? I'm not going to repeat this operation all over the other items. I'm just going to go to this one. I right click, copy, and paste by Control V. Again, Control V. All right, and then I need to copy or everything, and then select them and paste, and then do this trick and paste. This way you will code the questionnaire within I don't know how much time we spent, 21 minutes. Okay, so yes, so this is it. It's not that difficult if you know the trick. Then we need to just copy the last ones. Okay, so now if we go back to this these answers, you can see that they have been coded, and if we click this icon, you can notice the code. So this is questionnaire coding. Then what we need to do once we code this, by the way, I didn't tell you this. In fact, when you design the questionnaire, etc., don't let's say have all the respondents completed, because you need to pilot test it. You pilot test it on a sample of 15 to 20, let's say, respondents, and check the reliability of the scale, for instance. So this is like a Likert scale, and then we need to check its reliability, its Cronbach alpha internal reliability, to see whether all the items on the scale are about one construct, let's say, which is about, for instance, peak in anxiety or our ranking and activity, etc. You see, this is why we should test the reliability of the questionnaire, you see. So to test the reliability, I go to Analyze, and then I'm going to go to Scale. So remember, so I go to Analyze, and then Reliability, or rather Scale, what is it? And then Reliability Analysis, like this. Click on it. And then I need to move all the items at once. Okay, by Control A and move them here, and then I go to Statistics and choose scale of items deleted, etc. if I want to improve the reliability. And then the Cronbach alpha is already chosen here, so there are different tests like split hole, like test pretest, like parallel and strict parallel or parallel reliability tests. So I just go for the alpha, and then name this scale. So give it a label, scale, for instance, 1. And then click OK and wait for what will happen. So this is the reliability result. So now we need to interpret this. So I'm just going to take this reliability and then copy it and go to a sample I sent you for the reliability, and then paste it. But sometimes if we have different Likert scales, like imagine that this Likert scale has how many items? So 12 items, right? So I'm just going to put this, okay, 12 items here, and put that the Cronbach alpha reliability is how much? So I already pasted this reliability. So it's 44%. So this is how this can be interpreted. So it's 44.5%. Okay, we can keep it like this. But this Cronbach alpha is below the threshold level that is set by Cronbach and Shapiro 2000, or rather 1982. Therefore, the scale is not reliable. Now we are going to resort to the second table, which is about reliability items, if items deleted. So I'm just going to go back to the table, and I find this one and copy and then paste it. Okay. So these are the items, and this is the reliability if that item is deleted. Imagine that we delete this item, so this reliability will be or will have this value. We delete the second item, the reliability will improve to this extent. But we want it to improve till it reaches this level of 7. So hopefully we find one. Otherwise, we claim that the Likert scale is not reliable. But I think if we remove this one, when I work on the task, I feel bored, this item, for instance, and the reliability will be improved to let's say 61%, 0.9, which is good. It's still an acceptable threshold in, let's say, in the social sciences in general. So what we will do, we go back to SPSS and delete that this one. What is it? This one, and see what will happen. So we should remove it. We should not deal with it. When we ask the respondents, if the rate, we won't treat it when it comes to data analysis. So I'm just going to clear it. That's it. So now I can start analyzing this questionnaire. I can analyze it using descriptive statistics. So I can go to analyze descriptive stats and go to descriptives. And then I need to move all the items at once and then go to options and pick mean, standard deviation, minimum, maximum if I want them, sum, etc. and click. And I have this display order. Depending on the mean score, will these items ranked in terms of variable list as they are, or alphabetically, or ascending means or descending means? Let's check this one. And then click continue and then OK. You see, so based on the means or the mean scores, the items have been ranked. You see, so the most frequent item or the most frequently agreed with item is this item number 2. So when the items are difficult, just quit figuring out their meaning. So this is like a scale that has to do with another thing. You see, so the mean score can be interpreted this way. So this table can be interpreted based on the mean score. So this n means the number of the respondents, the sum when we calculate the sum of everything, and the standard deviation means how each respondent varies from the other. So this is standard deviation. It's called a measure of dispersion. It's a dispersion measure because we have measures of central tendencies and measures of dispersion within descriptive statistics. Okay. So then we can interpret this table. Now, yeah, imagine that I want to do a Chi-square test. So now we can move to, okay, so let's just stay a little bit on this. For the frequencies, we can analyze, for example, 2 items using charts. So I can choose pie charts or bar charts, percentages, continue, and then click OK, and wait for the output. Okay. So the majority of the respondents strongly agree that I work hard to learn the target vocabulary. So this is one finding. The second finding is that when the items are difficult, I just quit figuring out their meaning. So the majority of the respondents strongly agree as far as the frequencies are concerned. So I can just copy and paste all the items at once and paste it to Word and start working. Okay. So just do like this, paste, and here you are. Now we need just to write some commands, etc. Maybe we need to combine variables because we are not going to leave them this way, especially at the master and PhD level. But for other levels, maybe it can be acceptable. You can even copy these charts and paste them. I don't know, it depends on your supervisors. So anyways, just go back to what I have been doing, just to go back to so we stopped at what stage? The descriptive stats, okay? Because there are 2 ways. Now suppose that I want to conduct some tests like correlation tests or chi-square test. So chi-square test is used when we want to see whether or not there is any statistically significant association or relationship between 2 categorical variables like this one and this one. Okay, so I'm just going to go to analyze and go to descriptive stats and go to cross tab. So I need to put, I work hard to learn the target vocabulary in the row, and the other one, when I say that, okay, let's choose one. I was engaged. So let's choose these 2 variables because these are 2 categorical variables. And I go to exacts. I need to check some elements here. For statistics, I just go and check chi-square test. So this is so this depends on what I actually want to have on the output. So click continue, and then click OK. And here is the cross tab. So I was engaged with the task at hand. and I work hard to learn the target vocabulary. Okay, so, and this is the chi-square test. The chi-square test, you go to the sig value to see the sig value is called the p-value, and it should be below 0.05 to see that there is a statistically significant association between the two variables at hand. But this depends on your research questions and hypotheses, okay? Then we have other types of tests. But now I'm going to use another file, this one. Okay, but just while waiting for it to be uploaded, just I need to speak about you, or to speak to you about the difference between descriptive statistics and inferential statistics. So the difference is that descriptive statistics or statistical tests only describe the data, they tell you just the trends, etc. But inferential statistical tests, in fact, try to draw inferences based on the sample. You want to make some generalized facts, or rather finding, we call it generalization. I just find it hard to pronounce it now. So anyways, to draw some inferences based on the sample. So this is the main purpose behind, inferential statistical tests. So anyways, this questionnaire again has this variable of gender. So what I can do with gender is the test of the independent sample t-test. But before that, I need to compute the mean score of the Likert scale. So just to put you on let's say in the picture. So this Likert scale questionnaire is about homework assignment, and the respondents were asked some Likert scale statements to tell us how frequently they assign homework. Okay. So like I'm going to choose the statements, and I'm going to compute them and make them as a new variable, like regular assignment of homework. So that I can reduce all these 4 or 5 statements into one variable. So what shall I do next is that I'm going to go to where? To analyze, or rather to transform, and then compute. There is just to look for it, compute variable, and then I'm going to put the scale, like what assignment of homework. So just enter the name or the label. Okay, and then I'm going to move the items that correspond to this scale. But before that, I'm going to go here and look for statistical and mean and move it here, and then let's start doing what? So let's start moving the items one by one, like this. Okay, so let's just move the others till we finish. So this function on SPSS, what actually this function does is that it just summarizes this, or summarizes all these items and mix them into one variable. So I hope you get the meaning. So once we finish, we click OK, and new variable will be created. It's going to be labeled assignment, so the label that we gave it earlier. Then once we have this label created, so it's going to be a continuous scale. So what we can do with it is the independent samples t-test. So we can go to analyze, and then we go to compare means, and then independent samples t-test, and I move the gender to the grouping variable, and that variable of regular assignment of homework to the test variable. We want to see who assigns homework more, female teachers or male teachers. So this is like the research question for this test. So I still need to define groups. So I coded them as follows, like 1 and 2, and then options. And so I just keep it this way and click OK and wait for the output. So this is the independent samples t-test, and this is the mean. So as you can see from the mean, if we want to compare the two groups, who assigns homework more. So the group that does so is related to the female group. So we have, or rather the male group, as the mean score is higher. So we have the male group, or has a higher mean score compared to the female group. This means that male teachers in that case study that you investigated assign homework more frequently than female teachers. Okay, and then you can give them some interviews. But this finding is not statistically significant. Therefore, we cannot generalize it to the population. So the independent samples t-test shows that there is a statistically insignificant difference between male and female teachers with regard to the frequency of assigning homework, in the sense that male teachers assign homework more frequently than female teachers. So this is like the interpretation that can be drawn from the independent sample t-test when working on the gender variable, for instance. But we want to investigate whether or not there are some differences that are statistically significant based on age groups. So this variable should not have been entered this way. But anyways, let's see teaching experience. So based on teaching experience, we want to see who, let's say, assign homework more frequently. So are they, let's say, novice teachers or experienced teachers? So what would you think? So anyways, let's check this. I'm going to go to analyze, compare means, and I go to one-way ANOVA. This is the analysis of variance I told you about earlier. So I move the teaching experience to the factor list, and I move the other Likert scale variable to the dependent list, and then I'm going to go here and check what I want to have as the output. I can go for post-hoc test of LST if maybe I find that there is difference between different experience groups, but who does this more? Are the ones who have, let's say, 1 year or 2 years or what? So this is what this post-hoc comparison test does. So click continue, and maybe we go to options and choose means plot to picture this in terms of charts. So click continue and click OK. So I wait for it till it is displayed. I'm just going to go to the output, because on SPSS, remember, you need to keep saving your work because it doesn't have this auto save. Okay. So now we have the ANOVA, and you see that how we can interpret this ANOVA. It's like Chinese or Mandarin Chinese. So we can go to the sig value, which is the p value, and as a threshold that you should keep in mind is that the sig value should be below 0.05 so that it is statistically significant. If it is above 0.05, like this case, it is above. Therefore, there is no statistically significant difference between more experienced teachers and less experienced teachers as far as their frequency of signing homework is concerned. So what answers this question is the descriptive stats, because we combine descriptive stats with inferential stats. So again, look at this table of these descriptive stats. Okay, no, not this one. The post-hoc test, and you can see the mean difference. Okay, and here you see even the sig values that correspond to each group. So if you find that we have, in terms of experience, there is another table. Okay, let's just look at them in figures, because these are very confusing for the time being. Let's just look at this chart, means plot. This will help you visualize this finding. So as you see, this is the frequency of assigning homework on this side, and this is the range of experience. So 1 to 5 years, they assign homework less. 6 to 10 years, again. So there is this increase in terms of the frequency of assigning homework based on experience. Okay, so this is the finding that we can draw, but still it's not a statistically significant finding. It cannot be applied. Maybe it is peculiar to that situation, or rather that school that we investigated. So this is what this is how the ANOVA can be used and interpreted, because there are two ways of interpreting results. There are numerical ways, like looking at these figures and numbers and telling me this finding, or telling us this finding, or graphical way to interpret the data, like looking at this means plots and finding or locating, I mean, the difference. So these are like the two main ways. So this is for the independent sample t-test and the one-way ANOVA. So now let's analyze the survey using what? Using other statistical tests. Okay, I'm lost here between those. Okay, so now we have this scale. We want to compare, for example, or correlate the frequency of assigning homework with the beliefs about English homework. So are those students or teachers who have positive beliefs about assigning homework, or do those professors or teachers who have positive beliefs about assigning homework assign more homework or not? So this is like the research question. Is there any statistically significant correlation between the positive beliefs, for instance, about English homework and the frequency of assigning them? So this is another research question. So to test this research question, we need to do another test that is called correlation. And to do correlation, in fact, just showing you the straightforward way, but we should just check some assumptions, like this variable should be continuous, not a categorical variable like gender, etc. So this, if you remember, this is the composite score of the Likert scale. So we reduce all the items into one variable, if you remember this. Then we need to go to analyze and go to correlate if we want to conduct correlation, and we go to bivariate correlation, and I check because there are different types of correlation. We have Pearson, we have Kendall-Tobey, and we have Spearman correlation. So I can choose them both, and this is what is called sensitivity analysis, because you keep doing tests. We have a lot of data, so why can't we keep testing, like COVID tests? So we just sometimes we use different tests to make sure that, or tests to make sure that there is a problem or there is no problem. So this is my approach. I actually use the two, and this approach is called sensitivity analysis. And then I'm going to move the two variables, like regular assignment or the positive or the beliefs about English homework and the regular assignment of homework, and move them to this box and go to options. And I need to pick means and standards deviations and maybe cross product deviations and so whatever you want here, but you can choose everything, and you will have everything that is chosen on the output page. So it's up to you. Then click OK and wait for the output for the correlation. So this is the correlation, because we have the Spearman correlation or the Pearson correlation, that is parametric correlation, and we have the non-parametric. So Pearson is a parametric and Spearman is non-parametric correlation. So let's interpret this correlation, whether or not there are or there is a statistically significant correlation between the beliefs about English homework and the regular assignment of such homework, for instance. So the answer to this research question in your study is yes, there is a statistically significant and more than that, a positive correlation between beliefs about English homework on the one hand and regular assignment of homework on the other hand, as the p-value is below 0.05. So this is the p-value, and you can see these asterisks, so to speak, that mark this, let's say, this significant relationship. Okay, and how do we know that it is a positive one? It depends on the correlation coefficient. So, so the trick is that this correlation coefficient ranges from 0 to 1, and from 0 to -1. If it is minus, suppose that there is a minus sign, we can say that there is a negative correlation between beliefs about homework and regular assignment. If it is a plus like this, it is a positive correlation. That is, the more, etc. Like the more frequently respondents or teachers have positive attitudes towards homework, the more likely that they will assign more homework, or you see, or tasks, you see. So this is like the interpretation, and it is a positive, and it is statistically significant in the sense that this finding can be generalized. That is, this theory of assigning homework as well as the attitudes towards homework can be confirmed at this stage and based on this data. All right. So this is like the interpretation that we can draw from this, and I can just copy paste this table, or I can just still change it a little bit so that I make it compatible with the the APA style and the principles of publication. So that's it. I think this is for the first test, and I told you that I used two different types of correlation. So let's see the other test, and as you can see, the same finding is again proven in this second test, so to speak, as we have positive correlation, and this positive correlation is statistically significant based on the sig value. Okay, the sig value is the p-value on SPSS, okay? You remember that you should have this background information that the sig value should be below 0.05 if it is statistically significant. If it is more than 0.05, it is not statistically significant. Since in this case it is below 0.05, it is statistically significant. All right, so this is it for correlation. Then let's try to do other tests, if any, depending on the variables. So where is the sample that we have been working on? By the way, do you hear me, or I'm just speaking to myself, or just because I feel that it is calm? All right, thank you. Yes, yeah, we can do Q&A at the end. Yeah, because this is technical. These are like technical procedures. I know that before that you should develop this background knowledge. So you should go and read about descriptive stats and read about inferential stats, etc. Because this is why SPSS is difficult. It's not difficult to keep clicking these icons. I mean, but what is difficult is the knowledge per se, to know what the t-test is, to know what an ANOVA test is, and to know what correlation test is, and what, for instance, other tests and how they can be used. So this is like the trick. So if you want to improve yourselves in data analysis, you just go and read about it theoretically, then you go to practice. So, but anyways, let's just continue, and I'm going to assign some minutes to a Q&A session. Yes, thank you, Professor Zaid. Okay. Uh, so far we have talked about independent sample set. Okay, descriptive stats like frequencies and percentages, mean score, standard deviation. Then we talked about independent samples t-test with the you know the gender group, and we talked about another test was ANOVA when we have more than two groups like education level. And we talked about what? Correlation when we have two continuous variables that should be correlated, like the one that I have just done. But, okay, what is it? So, and then I talked also about, we have talked, in fact, about Chi-square tests. I mean, if you know these tests, it's enough. Just you can, if you are at the PhD level, you manage to do the analysis. I mean, of your dissertation or you know, questionnaire, so to speak. But if you want to go more advanced, you can do factor and analysis. You can do logistic regression, simple linear regression. You know, so factor analysis, just to give you an idea about it. Let's go to this questionnaire. So this questionnaire has a lot of items, but we need to group these items into factors or simply themes. So we want to group them thematically speaking. Let's say different types of what? So the text or this article is talking about factors affecting writing anxiety. So we can have different factors like internal factors, external factors. I don't know, different types of factors. So the items can be, if we use this, let's say, factor analysis, we can assign each, let's say, factor set of items that correspond thereto. So this is for the factor analysis. So I'm just, okay, if I can just use another strategy. Okay, so if you can see my screen. So I'm going to type for you, and because I know that some students and researchers are watching from their mobile phones. So the thing is that when we are, so when we have the study, okay, uh, when we have study, we should think about the variables. Okay, like the variables can be defined into or can be grouped into dependent, okay, dependent and independent. As far as the study design is concerned, like this one, this study, we have two dependent and independent variables just from the title. So the dependent variable is about writing anxiety, and the independent variable or variables are the factors, okay? Or maybe sometimes the gender, it depends. Okay, so now we need to think or differentiate the two types of variables in terms of study variables, but there are variables in terms of levels of measurement. Levels of measurement. So variables in terms of the level of measurement are grouped into categorical, or nominal, ordinal. I'm going to share with you the notes later. Ordinal, what else? And interval and ratio variables. So let's just give examples so that you can understand. So categorical variables are variables that are in the form of categories, like gender is a categorical variable in the sense that we have male and female respondents, two groups. Ordinal variables, just from their name, this means that these are variables that can be ordered or ranked. Like what? Like Likert scale items from strongly disagree to strongly agree. This one can be considered an ordinal variable. Then we have interval and ratio variables like age, because both these variables are, let's say, continuous variables. Age, like when not when you ask about age groups, but when you ask about how old are you, and the respondents give you the exact age, or the score, like in this case the writing score. Okay, the tests. So these are the variables. So then when you master the variables, you start coming up with the research hypothesis to see the interaction of the variables. So the research hypothesis, like there are two types. We have the null hypothesis and the alternative one. And there is also the directional, etc. But there are, in fact, I'm just telling you that there are many so that you can go and read about them. So this is just an introductory session. We have null and alternative. So null hypothesis assumes that there is no statistically difference, let's say, between gender and anxiety level. Okay, like in this case, we have male and female. So this studies investigates gender and writings students writing anxiety. So this is the dependent variable. So the alternative, or the null hypothesis, states that there is no difference. There is no difference between what and what? Between male and female respondents or students, and female respondents or students in writing in anxiety. So this is how it can be written. This is your research hypothesis, for instance. Then we have the alternative hypothesis. It's very simple. You just take this one and you remove the no particle therein, so that you can see that there is a difference between male and female respondents in writing anxiety. So this is like the alternative hypothesis. Okay. So this is it for the null and alternative hypothesis. Then what? When we do hypothesis statistical testing, depending on the type of hypothesis, we can start suggesting, or rather proposing, some tests. Like here, we can use independent samples t-test to see whether or not there are differences. Independent samples t-test to check as far as the data collection and the data analysis procedure are concerned. And then, so this one can be analyzed using independent samples t-test, and the same for the other one, because the independent samples t-test can tell you whether or not there is any statistically significant difference between male and female respondents. What I advise you to do is that you can go and insert a table like this. Okay, here you put your research variables, and then I'm just going to highlight this further for you to see. So anyway, so you should just come up with a table like this, in which you put, for instance, research questions, research variables, and tests. Okay, I'm just going to redo this. So we said that's a table like this, in which you put research question, research variable, and tests, and sometimes the results. So suppose that a research question, is there any difference between female and male students in terms of anxiety, for instance? So this is the research question. So I should write it so and so. And then for the research variables, I should group them like this. So I should group them as dependent variable, and I put anxiety, for instance, and independent variable, and I put, for instance, the other one, gender, male and female groups. For the tests, I'm going to choose independent samples t-test. Dependent samples t-test. Just ignore the typos for the time being. Just type in fast. So anyways, when we finish this, we do what next? We just go and start. So this is like research design. Sometimes we can add even the results when we finish to see the main, let's say, results here. There is, for instance, difference in favor of female respondents. So female respondents become more anxious compared to, for instance, male respondents in terms of anxiety. So this is like this is pretty much it. So this is like the how I can organize my research design, so to speak, or rather visualize it or make it in a chart or table like this, so that I can see exactly what I need to do. So remember, so these are research questions, research variables, and tests and results. Again, suppose, so depending on the types of research questions and the variables, you can suggest a test. Like if we have, again, for the deep, we just copy and paste everything. We change just the independent variables, and we make it, for example, education. Okay, like first year, second year, third year. Since education is a categorical variable that has more than two groups, we can go, instead of independent samples t-test, we can go for ANOVA. Okay, and we can find the results when we conduct the test. We can find that freshmen may have anxiety more than sophomore and then the other ones. Okay, senior students, for instance. Then we can go and investigate another thing, like correlation between, is there any relationship between what and what? Like, for example, age and anxiety. Okay, like primary school students, etc. And we can do here correlation test, and then we see that the result, whether there is a positive or negative correlation. Okay, so this is pretty much it. And then if we, so this is like, these are the tests that are most common. I don't want to tell you about regression and binary logistic regression and factor analysis and other things, dummy coding, because these are a little bit advanced and you don't need them anyways. Just for the time being, focus on these three common tests, like independent samples t-test and ANOVA and correlation, as well as the descriptive stats. And I think I will give you the floor to interact. I think just to review this, we talked about how to, as an overview, how to design a questionnaire using Google Form, how you can share that Google Form with other students or researchers, how you can in fact adapt questionnaire from other studies by just going to Google Scholar and looking for some studies. And once you start collecting data, use a sample that is like of 20 or so students or researchers or respondents, so to speak, and then do the pilot testing. You import that and you start doing the pilot testing, and namely you test the Cronbach alpha reliability by going to scale reliability, moving the items here, and interpreting the reliability. This is the next step. Then you spread that questionnaire on a larger scale, and when we have the results, we can start analyzing them using let's say analyze descriptive stats, or compare means and using one-way ANOVA and independent samples t-test, or using correlation tests if there are two, let's say, what is it? Correlation tests if there are like two continuous variables. And I think that's it for the time being. Thank you so much for listening. And now we give the floor to questions. Thank you, Professor Zaid, for in fact coordinating this session. You told me that there are some questions. Did you make notes of them, or because I think you can just tell me? Okay. Okay, I'm just going to go to the chat box. Okay, I'm just going to scroll. Will you share the recording with us later? Yeah, it should be interactive so that they can benefit. Otherwise, I will. Okay, so there is one. Open queue and let's start signing. Okay, yes, Mr. Sabiri, I'm going to, or before, how can I just give them this? Okay, we need to allow them to share the, to to activate their mics. I think so. Uh, Otherwise, just let's answer the questions that are just written in the chat box, and then let's proceed. So you want to code questions from on SPSS. Well, you can do that, but it will be more demanding. I'm telling you the shortcuts. This will take you forever to do it. I mean, in terms of time, um, because SPSS has this traditional coding technique. I can just share. So I'm sharing the screen with you. So I'm just going to show. So you can go here and then okay to the variable view. Like suppose that we want to code the gender. So I go to replace this place and I start coding. Find the male and female. It's like Excel. It's pretty much the same. It's okay. What is it? So I said that we go to this icon. Okay, and replace, and you can code it from this place. But Spaces does not allow you to select as many variables as you can. That's why you can use, let's say, Excel. You can also, as we imported the file from Excel to Spaces, suppose that you did, let's say, you submitted the questionnaires in person, you can enter the data and you can do the reverse. You can export this what this data or these data to your Excel. So you can do the reverse. I'm just looking for it. So we have import and we have export. This one. So I can again do the reverse and export it to Excel like this, and it will tell me whether I want to keep the names or the labels. So the difference between the names and the labels is as follows. The difference is that names, you should not allow any spaces between, let's say, names, whereas labels are the ones that you can alter because this is like a programming language. So the programming language does not tolerate, let's say, space and other weird symbols. So this is on the one hand. You asked me also how you can code multiple choice questions. This is a good, let's say, question that you, because many researchers suffer from this. There is this, let's say, option here, the analyze, and it's called multiple response. Okay, so you go to analyze and multiple response and define variable sets, and then for age you move it and you try to give other options. Like for female, you name it, or rather you label it as chosen not chosen, male or chosen not chosen. So you start recoding the this. There are some videos online. I can share them with you so that you can follow the exact procedures. But yeah, this is possible to do. Don't worry about it for the time being. So let's go back to the, so the lower the standard deviation is, the more it supports my hypothesis, the higher it is. So for the standard deviation, okay, so the standard deviation is just a measure of dispersion. It falls within descriptive stats. You go and open your browsers, you type descriptive stats, you start reading, you will start understanding uh, from, let's say, online, just general articles, regardless of technical issues. But okay, the standard deviation simply tells you how each respondent differs from the other. Suppose that suppose that you are testing a class of students, and you want to see how each student differs from the other in terms of the grade or the score, and you find that there is a difference of some students get 7, others get 18. So there is a large difference. This is the standard deviation. Okay, so how each respondent differs from the other. And so the lower it is, in fact, studies say that the lower the standard deviation is, there is this homogeneity, and the larger it is, there is this heterogeneity of the responses. Okay, So to see whether the class is homogeneous or heterogeneous, so to speak. So this is what the standard deviation can tell you. Apart from that, I don't know, just what you can do with it. So what should I look for exactly when pilot testing? So while pilot testing, okay, remember, we don't pilot test the whole questionnaire, the gender and education levels. No, don't care about them. What you should pilot test is the Likert scale items, because I will tell you why you should pilot test the Likert scale items. You know why? Because the scale is about, for instance, anxiety, writing anxiety, the one that we have just studied, this one. So those researchers in Indonesia are studying writing anxiety. Where is it? Where is it? Okay. So the scales should all of the items should. This means that all the items on this scale should measure one thing, which is anxiety. Like while writing in English, I'm not nervous at all. This may need to be recoded or reverse coded, because don't use let's say negatively worded items in your questions or questionnaire. They might have yeah, you see the R, they might have reverse coded it. Okay, this is another technique. You can note it down. It's called reverse coding of negatively worded items. Then we have, I feel my heart pounding when I write English compositions under time pressure. And while writing English compositions, I feel worried and uneasy if I know they will be evaluated. You know, there is this extrinsic motivation and external factor about, grades, etc. in exams. So you see, all the items investigate one construct. We call it a construct, which is anxiety in writing. So I should not find questions or items here that talk about anxiety in speaking, for instance. Therefore, I need to remove it. So that's why I use reliability. So I use so reliability helps me refine or polish my questionnaire. Because sometimes you will have to do it yourself, but for students at the BA level or even at the master level, please go and look for it from other studies. Don't do it by yourself, because I know the time pressure and many things, you may not do it properly. But for PhD students, please try to design one by yourself, looking or adapting by adapting other scales. But even well-established scholars try to adopt questionnaires as they are, and they try to test their reliability. I hope this answers the question, so that you can measure one thing, because reliability means consistency. So all the items should be consistent, and the majority of the respondents should either agree with them or disagree with them, so that we have this consistency. So I think, I hope this answers the question. So I'm just going to go back to the chat box. Okay. Yes, if you want to say something, you can manage time, because sometimes I may keep speaking till what I'm saying may not make sense to you. So the presentation now, they include multiple response questions using species syntax. So the tables in species are in the APA. Okay, this is good question by Ishraq. Okay. This is for productivity. You can go to SPSS, and you can go to edit, and you go to options. Okay, so remember, you go to edit and you go to options. Okay, remember, edit, options, like I'm showing you how to install an app. And then you go to where? To tables. Where is it? We have the outputs and we have the table. Just some colorblind. Yeah, okay, so pivot tables. So we have APA times normal. I check this one, and I just check apply, and it will produce tables like the ones you have just seen. Because you won't need to format them. That would take you much more time. So it's better that you have them formatted in APA. So you need just to once I copy and paste them to, let's say, this Word, you can simply add what? Just you add table number and the title. You can say, for instance, if you are using APA 6th edition, you can do it like this. If you're using 7th edition, you can do it like this, like table 7, okay, or 1. Correlations between, let's say, beliefs and etc., etc., etc. You see, so this is like how you can go about, putting or formatting tables in APA format, because there are 2 editions, like the 6th and the 7th edition. It's better to use the latest one. Sometimes you need to refine this better because there are different templates. You can just remove some redundancies, etc. But I'm not going to go to them for the time being. Okay, the tables on SPSS. How do I put multiple? I think I answered this question. Okay. Yeah, you can interact